So let's talk about how to apply coding standards and naming conventions in your application environment. So as I mentioned in the previous video regarding rules, the first thing to do is set some rules. Then you need to think about how to systematize, automate, and validate rules. Now, what I'm not going to do in this video is talk about in detail my suggestions for coding conventions, naming standards. All local variables should start with L underscore, all cursors should end with underscore occur. Those things are important and you should have a set of coding standards, but it doesn't make sense to take the time to go over them in detail. So the point here is you should decide on your standard naming conventions for all your objects. That's most important. And then you should put them into play. Now, if you don't already have a document that has these kinds of naming standards and coding conventions, it's really tedious, rather boring to write one. So feel free to go out to this URL, examplesO'Reilly.com or best practices, and you'll find a link to the website for my Oracle Best Practices book, Oracle PL/SQL Best Practices, and you can download a predefined set of naming conventions and coding standards as a Word document or HTML document off of that website. So if you don't have one, try using that one as a starting point. But I think it's very important that when you take a look at setting naming standards and coding conventions that you go beneath that surface level of how do we name things and think about how to standardize and set rules around the construction of your programs themselves. Because all the program units we build, all our procedures, functions, anonymous blocks, should be built in pretty much the same way. For example, I would suggest, as pretty much everybody does, that you have the same program header comment block. So at the beginning of every one of your programs, you have the author and you have the copyright information and so on. In addition, I think that every one of our executable sections should have its own initialization and cleanup sections. And you need to make sure that all of your exception sections rely on your standard error manager, etc., etc. It's actually pretty easy to come up with a fairly long list of things along these lines. And again, rather than me come up with that long list for you now, what I want to talk about most is how to set about systematizing and automating your standardization around the way that you write your code. And one of the best ways to systematize, to create new habits that reflect your naming standards and coding conventions, is to use the code templates available in your IDE, your integrated development environment, like Toad or SQL Navigator. And the idea here is that you can create templates that define starting points for creating new things in your programs, like new procedures, new functions, new packages. You can build checklists directly into these templates. Don't forget, do this, that, and the other. And pretty much every IDE has its own approach to doing these code templates or code snippets or code libraries. And I'll give you an example of doing this with Toad. And then I'll come back and talk about automated formatting. So first of all, let's take a look at using templates in Toad to standardize the development of new packages. So let's switch over to Toad. I'll create a new window. Now suppose I have to create a new package. Probably what a lot of you do is something like this: create or replace package. My name is, and then you start writing your procedures, etc., etc. And if you write from scratch your packages in this way, in other words, if you face the white screen of non-productivity, it's going to be very hard to standardize and very hard to be productive. Here's the approach that I take. When I want to create a new package, I type std pkg, press Control space. It asks me for the name of my package. Let's say Practical Best PL/SQL. Press OK. And here's the starting point for my package. Here's the name of the package automatically inserted. Here's my standard header that I can now fill in. But more importantly, let's take a look at the package body. And in fact, within the package body, I have a standard template for procedures and for functions. Let's take a look at the function version. Obviously, it's not ready to go. You have to put in your own parameters, names, data types, etc. But again, the idea is to jumpstart a consistent starting point. So let's take a look at what I've done here. In the main body of code in my function, I have, first of all, a checklist. Don't forget these things. Don't forget to use bulk collect and for all for multi-row SQL. Hide your rules behind functions. Hide SQL statements, etc., etc. So some basic reminders. Of course, you can make these whatever you want. And I'm going to show you how to do that in just a moment. But in addition to my checklist, notice I have initialize and cleanup. I've created two separate procedures These are called local modules, and I'll be talking about this technique in Say No to Spaghetti code or extreme modularization. But inside a procedure, you can create other procedures and functions. And the idea here is that my initialized procedure isolates together all the startup logic. So validate my assumptions, validate my parameters, assign values to my local variables, etc. All collected in one place. And all my cleanup logic, for example, I might be having to close a cursor or close a file, is in one place. And there are several advantages to this approach. First of all, what I'm doing is taking out all the logic from the main body of code and hiding it, so that the main executable section really focuses on the executable section of that program, not the setup and teardown. In addition, by isolating my cleanup, I also can remind myself to do my cleanup when an exception occurs. So notice I have a template for my exception section. Don't forget to clean up here too. And also don't forget to use your standard error manager. I'll be talking about this particular error manager, the Quest error manager, in the next section of this video series. But whatever your choice is, you put one of these in your templates, and then the person who's building a new package has to take it out and put in something else. They won't do that. They'll keep this in and they'll change it to their requirements. So they'll be following the standards, establishing those new habits. Finally, in my function body, at the end of the body, I have a single return. And what I'm doing here is reminding myself that the best structure for a function is that the last line in the executable section returns the value, the return value. And all the rest of my code funnels down to that single last line. And by taking this approach, I can avoid multiple returns in my executable section, which is much harder to debug. And also I can avoid the error function does not return a value, which is a rather embarrassing error for a programmer. Now, as I mentioned already, you could put whatever you want in these templates. The point is to avoid writing a new program by starting with a blank screen and typing create or replace, etc. Now, the next question will be, well, how do I create these great templates? Well, suppose you define the template, you define the structure of the code, and by the way, if you go to my demo zip file and download it, you will find in the demo zip, as is indicated on the PowerPoint slide, you'll find these three files. And we're going to take a look at the standard package format first. So I've created a template that you can use, or at least use as a starting point. So suppose you open up standard package format. Here it is. Pretty much the same as you saw already. And I like this. I want to save this as my starting point for a package. So I'm going to grab it all, copy it into the clipboard, and then I'm going to choose editing options inside Toad. And in 9.6, the latest version, right at the top level in languages, I can see code templates. So I click here. I say that I want to add a new template. I give it a name like standard. And I can give it a description, standard format for a package. Press OK. Paste in my code. Press OK. And now, when I'm about to write a new package, I can type std, control space, and it finds my template, allows me to specify whatever values I have for arguments, and there's my starting point. So creating these templates are quite easy to do in Toad, very easy to access and to edit, and these templates are not only useful for this kind of broadly defined standard and starting point, but you can also do it for little things. For example, when I check for errors in my exception section, I often want to call format error stack, or DBMS utility format error stack, or DBMS utility format error backtrace. That's a lot to type. So I've created templates in which I can type FEB format error backtrace, control space, and there it is, format error stack. There it is. DBMS output.putline, I hate typing that, do PL, and there it is. So you can use these templates as really fantastic productivity accelerators, having you write less, and just basically anytime you're writing code and you're thinking to yourself, this is really boring, why am I writing this over and over again? Take that code, save it to a template, make it available inside your editor. And you can make this actually available over a network file so that everybody in the team can use the same set of templates. So that's an example of using these templates to systematize the process of following standards for writing your code. The other file mentioned here is the workaround comment, just to briefly touch on that. When you have to write a workaround, which we all do at some point or another, what's really important is that you document very clearly what the workaround is about. And you might want to use this template as an example. Usually you hit a bug somewhere that requires a workaround, so you can describe the bug. You can give some information about the Oracle versions it appears in. The bug reference might be the bug number. Then provide a description of the workaround. What do you have to do right now to get this to work? And you can actually put here at the bottom what the post-bug fix should be. In other words, you know the right way that you want to write the code. You can't do it today because there's a bug. So you write that code, you put it in this comment, and then you put your workaround code inside stubs like this. And the advantage of this kind of comment is that later on somebody can come along, verify that the bug is fixed, and they know exactly what to do to get rid of the workaround and put in the bug fix. So there are lots of ways to go about doing this kind of thing, but the point is to standardize it, to create these templates, make them available so that anybody in your team can use them and apply them quickly. So that's addressing the idea of systematizing the following of coding standards and naming conventions. Let's talk about automation. Here's some really ugly code. Line breaks are all over the place. There's really no standard consistent formatting. It's very hard to read. And in the bad old days of doing Oracle, and remember I've been doing this for over 20 years now, I used to spend a lot of time manually formatting my code to get it just right. And I'm really fussy. I have a specific way that I want my code to look. And I'd spend a fair amount of time manually reformatting. I hope none of you do this anymore, but I just want to make sure you know that in Toad and SQL Navigator, virtually any decent editor, there's automated pretty printing or formatting. So inside Toad, I can press this double yellow arrow and it formats my code. I can also right mouse click, format my code. And most simply, I can do Control Shift F and format my code. And if you don't like the way the default format looks, just go to View, Formatting Options, and you can pretty much change it to whatever you want. It's a very, very flexible, powerful parsing and formatting engine. So never take the time to manually format. Use the automated formatter. You can set a standard format for you that you like, that maybe nobody else likes in your organization, but it's what works for you. That's fine. You do that, and when the code goes into QA and into production, it can be formatted to the standard for the team. So you get the best of both worlds. Never manually format your code. So that's an example of automating the process of writing high-quality code. So that finishes up the topic of coding conventions, systematizing and automating them. And now we're going to move on to taking a look at spatification of your code, creating a single point of definition for everything you do.